The Autoignition temperature or kindling point of a substance is the lowest temperature at which it will spontaneously ignite in normal atmosphere without an external source of ignition, such as a flame or spark. This temperature is required to supply the activation energy needed for combustion. The temperature at which a chemical will ignite decreases as the pressure or oxygen concentration increases. It is usually applied to a combustible fuel mixture. Autoignition temperatures of liquid chemicals are typically measured using a 500 ml flask placed in a temperature-controlled oven in accordance with the procedure described in ASTM E659. When measured for plastics, autoignition temperature can also be measured under elevated pressure and at 100% oxygen concentration. The resulting value is used as a predictor of viability for high oxygen service. The main testing standard for this is ASTM G72. Autoignition equation: the time it takes for a material to reach its autoignition temperature when exposed to a heat flux is given by the following equation, where K equals thermal conductivity, I equals density, and C equals specific heat capacity, of the material of interest. Is the temperature, in Kelvin, the material starts at, and is the heat flux incident to the material. Autoignition point of selected substances: temperatures vary widely in the literature and should only be used as estimates. Factors which may cause variation include partial pressure of oxygen, altitude, humidity, and amount of time required for ignition. Generally, the autoignition temperature for hydrocarbon air mixtures decreases with increasing molecular weight and increasing chain length. The autoignition temperature is also higher for branched-chain hydrocarbons than for straight-chain hydrocarbons. For paper, there is considerable variation between sources, mainly because there are many physical variables over different kinds of paper, like thickness, density and composition. In addition, it takes longer for the combustion of paper to start at lower temperatures, see Fahrenheit 451. See also, pyrolysis, fire point, flash point, gas burner. References. External links: analysis of effective thermal properties of thermally thick materials.